let's discuss the difference between three different pressures. And this is related towards the pressures within fluids. So the three pressures that you should know a distinction between is absolute pressure, gauge pressure, and then atmospheric pressure. So the absolute pressure, how you can think about this, and it's drawn out here as an equation, but I just would want you to think about as the absolute pressure as the total pressure. So that is the summation of all the pressures that you have that are present, okay, at a particular point that you're interested in. So it's all the pressures combined. Now, all of those pressures, typically you can sum up in two things. You can sum them up in knowing what the atmospheric pressure is, and this is the pressure from the atmosphere. So you have pressure from the atmosphere. The atmosphere is a fluid, so it's a gas. And in fact, the air itself is the gas made up of many different particles, so from oxygen, carbon dioxide, and many others. Now, because those particular particles are within the atmosphere, so they're a certain distance away, okay, from the actual Earth's surface, so as long as you're somewhere near the Earth's surface, you're going to have these particles which are going to be on top of you. And they're creating pressure, because if you think about pressure in general, okay, and if you're thinking about pressure within a fluid, and gas is a fluid, then you know that if you do have a weight which is up above you, you're going to have this pressure which is going to be present. Now, that atmospheric pressure, okay, is standard, and we typically would simply just say this is, 1 atmosphere. Now, that 1 atmosphere, so the ATM, is just a unit, and it just simply means the pressure due to the actual air or the atmosphere itself. Now, if you wanted to be able to know what that 1 atmosphere is as a comparison to other units of pressure, okay, so that would be, and I've actually kind of written it down here, so you would have that 1 atmosphere is actually quite a bit. It is equal to 101,325 pascals, or 14 point, approximately 696 pounds per square inch, which is about 760 millimeters of mercury. Now, pascals you're used to most of the time because of the fact that you define pressure in SI units in pascals. Then you, of course, can also use kilopascals just as a prefix. The pounds per square inch and the millimeters of mercury you may get more acquainted with as you do more and more examples. Millimeters of mercury definitely comes up in blood pressure, right? So you do see these units. But the key thing that I wanted to point out is that 1 atmospheric pressure that we're referring to is basically a standard. It's always there near the Earth's surface. And we're always going to be assuming that we're kind of, right on the surface. So, give or take, ever so little. But we can approximate it just by saying, okay, this is 1 atmospheric. So it's always there, which means that this total pressure or the absolute pressure that I was referring to really means, okay, so it is this atmospheric pressure, which is a given, it's there, plus any other of the pressures that might be present at that moment. And that we call the gauge pressure. Gauge because we're actually reading it out and we're comparing this, okay, in comparison to the atmospheric pressure. So the gauge pressure is going to be, here is your atmospheric pressure, it's 1 ATM or 101,325 pascals. And then the gauge pressure just says, okay, how much above that you are or how much below that you are. If the gauge pressure reads 0, that means you're at 1 atmospheric pressure. And that would be your absolute pressure because there's no other pressures around. If you are above, so if the gauge starts to read a reading, okay, of whatever it might be, okay, so if it's above it, you're going to notice that it's a positive value. And what it's saying is, okay, it is that much above the atmospheric pressure. And therefore, you can, if you add the two, so if you're adding that difference, okay, so the atmospheric one plus the difference, okay, is going to be equal to the absolute pressure. If the gauge is reading below, so if it's below the actual absolute, so it's going to be negative. So that just means it is under, okay, the atmospheric pressure. Now for fluids, okay, as you're doing this, fluids typically push. So they push in some way. So there's not really like a pull. So it's very rare that you might see a negative value. But there are instances where it can happen, okay, where you might have a negative value. But most of the time, you're going to see that the gauge pressure is going to be positive. So to give you an example, if you're thinking of, reading the pressure within your tire, okay, if it's reading 0 and you're reading the actual value, that 0 just simply means that that is the gauge pressure that you have. And that gauge pressure just says that, okay, whatever, you have a flat tire, but the atmosphere, so the atmospheric pressure is still present. But the gauge is just saying that that difference, okay, or the change in pressure is basically 0. And if you start pumping up the tire with more and more air, which what you're doing is you're putting in more and more particles within, so you're creating more pressure above the atmospheric, okay, that you have. And then it's going to be reading a positive value up above it. So that gauge pressure that we have is always the reading. So even if you are reading things like blood pressure reading, okay, so that pressure again is the gauge pressure that you have, because we have the atmospheric pressure present anyways, okay, everywhere. So unless we remove all the air from a container, then of course, okay, if you suck it all out, okay, and you're going to be at 0 atmospheric pressure, then the only pressure that could be present is, any others that you insert there. But it's very difficult, obviously, to try to suck out that particular air. So again, how you can think about this is in this way. So if you have some kind of a container, now you know this because of the fact, okay, let's say that you've studied something like, for instance, Pascal's principle, okay, or something of that nature. I'll put up a link up above there. Now, if you close this container, okay, like this, and now, and inside of it, you have some kind of a fluid, okay, and now within here you've sucked out, so there's no air, so the pressure right here is equal to 0 above the fluid. You know that you can calculate various pressures that you have, right? Now, what I'm saying here is, you can calculate the pressure at a depth because you may know the actual height, okay, that you are interested in, and you can say, I want to know what that pressure is at this particular depth or the height from the surface. So what you would have in here is you would have the following. You would say, okay, so that the absolute pressure is equal to, you've sucked out all the air, so the atmospheric pressure, okay, so there is none in there. So the absolute pressure in this case would just simply be whatever, okay, the gauge pressure is at this particular reading, which okay, for fluids, this would be just your density multiplied by gravity and then the depth that you are at, right? So this is the pressure due to a fluid. Again, a link up above there, okay, for you. So now you can certainly put that in here, and what you would have is this, and you would refer to this as the gauge pressure in this case, okay? The atmospheric pressure was 0. Now, what we do is, because of the fact that the atmospheric pressure, we don't really suck out the air, we can't suck out the atmosphere anywhere. So the reality is that we don't really have this covered. And as soon as you uncover it, obviously there will be air, the atmosphere, which will be present. So this is really not equal to 0, right? So this is going to be at an atmosphere, and this is at 1 atm, okay? Or we just say this is pressure atmospheric. So if you wanted to know what the absolute pressure is at this particular depth, and now you've uncovered it, and now that there is the air which is present there, right? So you do have the air which is present. So that would mean that the absolute pressure is this, which is your atmospheric pressure, plus you would notice that the reading at that value, okay, at that depth, okay, would give you this, and that is your gauge pressure that you have. And now what we do is when we're reading these in, okay, the gauge or some kind of a reader, this is always omitted because it's always present. So what's the point, okay, of actually asking us, okay, what's the absolute pressure, if we know that the actual absolute pressure really is the atmospheric pressure that's always present, plus whatever the difference might be. And this particular difference, so this right here, is the gauge pressure. So that is our gauge pressure that we have. And again, you can think of it as the change in pressure with respect to your atmospheric pressure. But typically, it'll just be called gauge pressure. All right? So this, okay, these are the three pressures that you should think about within fluids. The atmospheric pressure, which is always present unless you're in a vacuum and you start sucking things out. You have your gauge pressure, which is like your change in pressure with respect to the atmospheric pressure. So it's going to be either above or below, and it's that change, okay, from that. And if you add those two together, then you're going to get the absolute pressure, which is present. So that is it. Those are those three pressures. You should know them as a student, okay? These units that I provided you for the atmospheric pressure, so ATM, which just means atmosphere, PA, which means pascals, PSI, which means pounds per square inch, okay? So it's the force, which is in pounds, and the area is in inches squared. And then millimeters of mercury, okay, that's something that you're going to learn about now that you kind of start knowing about this gauge pressure, atmospheric pressure, and absolute pressure, because millimeters of mercury has come from a special case of dealing with mercury and the density of mercury, and millimeters actually meant and related to the actual height that you will have or the depth within these fluids. And that's kind of an extension to how you can figure out how blood pressure works. And that I'm going to do in a separate video. All right? So out of this video, absolute pressure, atmospheric pressure, and gauge pressure. Those are the three, okay, that you should be familiar with as you dive yourself into, okay, the world of pressure and fluids. Bye, everybody.